Alright class, Algebra 2, Lesson 32, Buying a House. So in the problem set of Lesson 31, there was a problem that asked about both a future career and a home you would like to purchase. In this lesson, we were going to use the information from that problem set to work through a few things, but I didn't assign that problem for you. So I've gathered some information so we can all talk about the same career, future career choice, and home, and work through some problems, some scenarios about buying a house. Cool? Cool. First of all, isn't this a lovely home? Fayetteville, $215,000. It is a 3-bedroom, 3-bath, single level, split entry, a nice starter home, okay? Might not be the home you live in now, or it might be nicer than the home you live in now, I don't know, but it's a starter home, okay? So $215,000. This was from the problem set, lesson 31. We are all going to pick the career of a registered nurse. You need a 2- or 4-year college degree plus continuing education, and the starting salary is about $57,280, which is an honorable starting salary, really. Okay. The other things I want to point out, the present value of an annuity formula from lesson 30. We've used that quite a bit. And then the above formula can be solved for monthly payment R. So jot these down. We're going to use both of these equations throughout this lesson. Yeah, so I've given you how much our home is going to be, what our career choice is going to be. Now let's model a few things. Cool? Cool. So today you're going to answer the following question. Can you afford to buy the house that you've chosen? $215,000. There are a few constraints that you need to keep in mind. The total monthly payment for the house cannot exceed 30% of your monthly salary. Monthly salary. If I do that times 0.3, let's see what I get. 57,200 times 0.3 divide by 12. 30% of my monthly annual, so that's how much I'm allowed to spend per month on a house, given my salary. Your payment includes the payment of the loan for the house and payments into an account called an escrow account. The bank holds some money for us, and they use that money to pay for taxes and insurance on your home. When you take out a loan for a home, you put extra money into your account. The bank holds it, so you're paying the bank back for the loan. You also give them extra money, and they put it into an account called an escrow account. And then the bank uses that money to pay for taxes and to pay for the insurance on your home. Mortgages are usually offered with 30, 20, or 15-year repayment options. 30 is usually less interest than a 15. Start with a 30-year mortgage and work your way to 15. You need to make a down payment on the house, meaning that you pay a certain percentage of the price up front and borrow the rest. You make a 10% down payment for this exercise. So 215, I don't need a calculator for this. Down payment. Cool. All right, still building some thoughts in your head and some vocabulary. What is the monthly salary for the career you chose? 57,280 divided by 12. 4,773. No, we're not taking into account healthcare, retirement, etc. Taxes, what the government takes from you, etc. Okay? What is 30% of your monthly salary? We did this in the last slide. Let's do it again. $17,184. How much money needs to be paid into the escrow account each year? Let's see. It hasn't told us that yet, but we need to keep that in mind. So we're going to hold on to this one. We'll get to it. How much money needs to be paid into the escrow account each month? We would take number 3 and divide by 12, but we're going to hold on to it. What is the most expensive house that the bank will allow you to purchase? This is what these are the things we're going to answer as time goes on. Is a mortgage like a car loan? Yes and no. A mortgage is for longer time usually. It's usually lower interest rate because it's for a longer time. Interest rate. A mortgage is a longer time, lower interest rate. A mortgage, has an escrow account. I can't think of anything else. What is the formula we used to model a car loan? That is the A sub P equation on the previous slide. Which of the values, A sub P, N, I, and R, do we know? If it's a home loan, we know that one. We'll know how much time. We'll know the interest. We don't know the monthly payment. Can you rewrite the formula to isolate the R? Yes, I did that on a previous slide. What is the monthly payment according to the formula? We're going to get there. So this we still need to do. This is what we're working towards. We did that, we did that, we did that, we did that. Okay. Will the bank allow you to purchase the house that you've chosen? This is what we're working on. Okay, these are the things that we're working on right now, okay? Alrighty. I know you probably think I'm talking in circles, but let's talk about it one more time. Now that you've studied the mathematics of structured savings plans, buying a car, and paying down a credit card, it's time to think about the mathematics behind purchasing a house. In problem set 31, you selected a future career and a home to purchase. Well, you really didn't, but I did it for you. The question of the day is, can you buy the house you've chosen on the salary of the career you have chosen? You need to adhere to the following constraints. Mortgages are loans that are usually offered with 30, 20, or 15-year repayment options. Start with a 30-year mortgage. The annual interest rate on the mortgage will be 5%. Okay, we didn't know this one yet. We're going to start with 30 years, 5%. Your payment includes the payment of the loan for the house and payments into an account called an escrow account, which is used to pay for taxes and insurance on your home. We approximate the annual payment to escrow as 1.2% of the home's selling price. The bank can only approve a mortgage if the total monthly payment for the house, including the payment to the escrow account, does not exceed 30% of your monthly salary. You have saved up enough money to put 10% down for the house. Okay, so we have that. Now the question of the day is, will the bank approve a 30-year mortgage on the house you have chosen with the career you have chosen? All right, so let's do some math. So first of all, we chose the career of a registered nurse, which is $57,280. So the monthly salary, I know we've already calculated this a few times, but I'm going to do it again. Monthly salary is $4,773.33. So 30% of my monthly salary is how much I can spend on a house per month. $1,432. So 30% of my monthly salary is $1,432. Cool. I found a home that I really liked for $215,000. Let's see, what do I need to do for an escrow? The escrow was 1.2%. So let's multiply it by 0.012. 215 times, 215,000 times 0.012. So this is how much I need for my escrow account. And that is per year. I have to contribute that each year, which means I need to figure out how much I need per month. Yikes, that raises how much. So that is each month. Just write that, that's per month too. And this is escrow. Okay, we're getting there, aren't we? I need a 10% down payment. So I'm going to multiply by 0.1. And that gives me $21,500 down payment. It's an awesome down payment. So I can subtract that from the cost of the house because I only need to take out a loan for the remaining. So that is what I need to take out a loan for. That is awesome. So I can think of the total amount owed on a house in two different ways. So the total amount owed on a house in two different ways. First, if I had placed the original loan amount, in our case it was $212,850, the original loan amount in a savings account, and earned 5% in annual interest, then the future amount in 30 years would be this being 30 times 12. Okay, so I could think of it that way. If we had placed the original loan amount of $212,850 in a savings account and earned 5% annual interest, then the future amount in 30 years would be that equation. Or if I had deposited a payment of R, because we don't know what that is yet, into an account monthly, and let the money accumulate, and earn interest for 30 years, then the future value is 1 plus I to the 360 minus 1 over I. Okay, those are the equations we were using yesterday. Okay? So I can think of them both the same way. And if you look, they're both a sub f. Okay, so let me get a new slide. I can set both of those equations equal to each other and solve. Alright, it's a few days after I made this video. I found a mistake, actually one of my students did. So appreciative. So I already fixed the mistake on the last slide, but I need to fix a few things here. Oops. So I calculated 10% wrong, which you didn't see because I've already deleted it. So I've got 193, 500. Okay, that's the original amount. What else? I think that's good. So yeah, my mistake. I'll keep correcting them through the video. So that gives me a sub p 1 plus I to the 360 equals r 1 plus I to the 360 minus 1 over I. Okay, which means I can solve for r by taking all of this and dividing it over there. Phew! Let's do it. R equals a sub p times I. So check, check, times 1 plus I to the 360. Check. Nope, sorry. Uncheck that. Check. All over 1 plus I to the 360 minus 1, which is all of that. There is our r, which I can actually simplify just a bit. I get a sub p times I over 1 minus that's a negative. Let me rewrite it. Cool. So write that down if you haven't already, because we've used that one, right? I mean, I've written it down for you already. So this is the formula for the present value of an annuity. For the present value of an annuity, rewritten to isolate R. Okay, now I'm going to put in the values I know. Oops. Oh goodness. So I know A sub P, which is the amount I need to take out on the loan, 193,500. I know I, 0.05 over 12, which gives me 0.004167 over 1 minus 1.004167 to the negative 360. Okay, crunch those numbers, and I get $1,038.80. Add how much I need to put in my escrow account, and that gives me $1,253.80. If you remember, given our salary of our job that we chose, I'm allowed to spend $1,432 on my mortgage. So I'm good, right? Oh, but we are not done. Okay? There's a different way we can think of it, and I want to discuss that with you. Back in lesson 30, we know that the present value of an annuity formula is given 1 minus 1 plus I to the n, negative n, over I, where I is the monthly interest rate, R is the monthly payment, and n is the number of months in the term. For this, just like the last slide, we say that I is 0.004167, N, we're doing 30 years still, so 360. A sub P is still 193,500. I'm going to rearrange this equation for R, because we're trying to figure out what our monthly payment will be. So I'm going to have A sub P times I over 1 minus 1 plus I to the negative n. Go ahead and fill in what we know. 193,500 times 0.004167 all over 1 minus 1.004167 to the negative 360. I crunch these numbers. I get $1,038.80. I need to add in my escrow account. And I'm good. Okay, that would be my monthly payment. And the bank is okay with that because it's less than 30% of my monthly income. Yay! Alright, so answer either A or B as appropriate. If the bank approves a 30-year mortgage, do you meet the criteria for a 20-year mortgage? If you could get a mortgage for any number of years you want, what is the shortest term for which you would qualify? Okay, if the bank does not approve a 30-year mortgage, what is the maximum price of a house that fits your budget? So the bank does approve a 30-year mortgage. Usually the interest rate changes for a 20-year mortgage or a 15-year mortgage. I'm going to go ahead and just look at what our monthly payments would be for a 20-year mortgage. So we're doing R equals 193,500 times 0.004167 all over 1 minus 1.004167 raised to the negative 240, which is 20 years times 12. Awesome. Okay, crunch those numbers, which I just did. I get $1,277.06, which sounds awesome until I add my escrow account. So that would be my, oops, made a mistake. That would be my monthly payment. And if you remember at a beginning slide, I was only going to be approved at $1,432 per month because of the job. Oh, per month? Because of the job I chose. So that's not going to work. I know we're pretty close. Get a bigger down payment, get a better job. I would not cut it that close for a mortgage because you are stuck with that payment for 20 years, okay? It's a long time to be short by $60 a month, okay? We're going to go ahead and look at B, though. I know the bank approved our 30-year mortgage, but I'm curious what the maximum price of a house that fits our budget would be. So let's go ahead and look at it. So the maximum that the bank allows is 30% of the monthly salary, which was $1,432. That doesn't include, yes, that has to include escrow and the loan amount. So that's how much I have per month to spend on a house. So if the total price of the house is, let's just say, H dollars, so the total price of the house is H dollars, then I will make a down payment of 0.1, and my loan will be 0.9. Some fun algebra here. Using the present value of annuity, I have 0.9h equals R. 1 minus 1 plus I. So I don't need the plus. 4167 to the negative n, we're doing 30 years, 0.004167. And we're solving for R. So let's go ahead and simplify this jumble mess here. Yep. All right. So R represents just the payment to the loan and not the payment to the escrow account. So we know the escrow portion is 1/12. Escrow was 1.2% over 12 months. And that's of the house value, right? So 0.012 over 12 equals 0.001 of the value of the house. That part got a little confusing to me, but it's okay. So that's how much I have to spend on the house. Sorry. That's how much I have to spend on the house. So I have 0.9. Oh, I'm in red now. Sorry. I've got 1432 minus my escrow. A little bit of a mess here. Alright, so I'm going to go ahead and, I'm going to divide both sides by, actually I'll distribute that. So 0.9h, 1432 times 186.282, 266,755.824. 0.001 times 186.282, 0.186282H. I'm going to add this to both sides. So 0.9 plus that. Nope, sorry. To fix my work, I did minus. Here I have now I'm in blue, 1.61, let's say 4H equals 266,755. Okay, I'm going to divide both sides by 1.614. And I get H equals, I think I've made a mistake somewhere. Because I would think my house would be, I'd be able to buy more than a $215,000 house, seeing how I bought a $215,000 house. Oh, I think I see my mistake. Nope, that's not it. Alright, I'm gonna look for my mistake. I'll be right back. I found it. Okay, I'm going to green. This value right here. I need to add 0.9 plus 0.186, etc. So 0.9 plus 0.186282. There we go. 1.08622H equals 266,755.824. So now I'm going to divide both sides by 1.086. Awesome. I'm glad I found it. 266,755.824 divided by that. There we go. The house that I can buy is $245,567.75. Don't forget that 75 cents. Awesome. Thanks for being patient. It's easy. It's nice to be able to find your mistakes sometimes. Oh, and I added a blank page yet once again. All right, the problem set's fun. I don't know. I never even thought about buying a house when I was your age, so please ask questions. If I'm using vocabulary that you don't understand, I can explain it to you.